Hello, I'm Soo-Kyung-moon. The paper I reviewed today is Technology Convergence Assessment by an Integrated Approach of Bot Topping Modeling and Association Rule Mining. This study was published in IEEE in 2025, and this study combined bot topping modeling with association rule mining, quantifies and anticipates cross-domain synergies to more accurately forecast emerging innovation clusters. Rapid evolution of technology necessitates a deep understanding of how different technologies converge, as this is crucial for fostering innovation and strategic decision-making. Technological convergence refers to the merging of previously distinct technologies, often leading to groundbreaking innovations and significant cross-industry impact. Considering the need for a better understanding of technological evolution and convergence, this study aims to develop a comprehensive methodology to evaluate technological evolution and convergence by integrating text mining and ARM techniques. The research questions are as follows. First, how can technology areas be classified based on textual data to identify technology convergence? And second, what is the relevance of the technological domain in identifying technological evolution and convergence? Technology convergence is a concept that describes a phenomenon in which previously distinct areas merge to blur their boundaries. And patents have been used extensively in empirical research on TC, covering diverse topics from technological capabilities to technology forecasting and spillover effect. The convergence of technologies can be noticed as evidenced by the interconnected nature of the technologies described. Analyzing a patent's IPC can provide a more structured and direct understanding of the technology being represented, since IPC represents the technological components of the patent. Patent documents are rich technical and legal information sources, providing detailed descriptions of inventions, claims, and prior art. Unlike previous models, BERT processes text in both directions, capturing context more effectively. SBOT is a modified bot network that allows for deriving semantically meaningful sentence embeddings. SBOT can perform large-scale semantic similarity comparison, clustering information retrieval, and so on, which are downstream tasks that have been difficult to perform with conventional BERT using sham networks or triplet networks. E-payment technology has evolved significantly over time, driven by changes in user needs and advances in information technology, and this is which is the area that this study selected for analysis. Proposed framework for this study is as follows. First section is the data collection. In this study, electronic payment technology was chosen for analysis due to the advancement of electronic payment technology and the increase in cashless and online payments during the COVID-19 in recent years. The data of this study were collected from the Lens patent database, and the keywords and IPC codes used in the search are shown in the table below. This process involved consolidating related patents within the same family, ensuring that each invention is represented uniquely. The second section is data preprocessing. An abstract and claims dataset, which is mentioned as a text dataset for uniformity and quality, was created from the collected patent data. These abstracts and claims were extracted and compiled into a structured dataset, serving as the primary input for topic modeling. And an IPC code dataset was developed alongside the text dataset. Third is the convergence analysis. This study employed the patent expert approach developed by AI Growth Lab for topic modeling, and this method uses BERT embeddings tailored for patent text. Using the text dataset, we applied the patent expert with a maximal marginal relevance of 0.5. Association rule mining was applied to the IPC code dataset to uncover hidden relationships between different technological areas, and it calculated each association rule's support, confidence, and lift metrics. Indicators for TC reveal relationships between distinct technological roadmaps beyond those of immediately related technologies in the chosen field. The indicator considers both the variety of technology categories and the variety of events that occur in the convergence space. The intention of formulating the convergence indicator after obtaining the association rules is to imply further the significance of the item set pairs obtained. And this research builds the final network for TC by employing confidence and convergence indicators as key components. In the case of this study, most of the research consists of visual expressions of trends, so in this presentation, I will briefly tell about what illustrations were derived from the research. A first figure shows the distribution of high-frequency IPC codes, and second figure and third figure shows the distribution of top applicants according to two different criteria. After applying the patent expert topic model to the processed corpus of text data, this study analyzed the top 10 topic representations. According to Table 3, the top 3 topics obtained had more than 1,000 patents, and the topics included charging robots, radar antenna, malware risk and security, wearable devices, and so on. The coherence score obtained for the topic model was 85%, which indicates a robust topic modeling classification. As you can see in Figure 10, the top 5 topics have a higher periodic distribution of topics, and most of them have accumulated since 2008. For applying the ARMFP growth algorithm, we needed to decide the mean threshold value for the algorithm. The higher the approval rating, the more association rules are generated based on the IPC closest to the technology, while too low a threshold creates non-critical rules. In this study, we measure 3 minimum threshold intervals like this, and the time required for the rules obtained for each minimum threshold. As a result, time is regarded as a linear function regardless of the minimum threshold, but the number of rules is highly affected by the minimum threshold, so the median value of 0.05 was selected. It shows the associations between IPC codes within payment patents, and the reliability score indicates the strength of these associations. The reliability calculated through the FP growth algorithm measures the likelihood that the preceding IPC code leads to the subsequent IPC code and reflects the conditional probability and frequency of this association. reliability is very useful for understanding existing relationships, but CI captures the essence of technology convergence by providing a broader perspective on how technology interacts and evolves together in different fields. In conclusion, this study advances prior methodologies by integrating bot-based topic modeling with ARM to enhance the robustness of convergence analysis, and the introduction of novel convergence indicator further enhances this methodology by incorporating lift confidence metrics, providing a more precise and scalable assessment of multi-domain technological linkages. And this study extends convergence analytics to the e-payment domain, enabling a refined assessment of technological synergies in financial and cryptographic payment infrastructures. Unlike previous approaches that primarily examine isolated domains, this study offers an integrated perspective on multi-domain technological interactions, enhancing the predictive capacity for future technological shifts. Furthermore, and this study refines patent-based decision support mechanisms by incorporating BERT-based embeddings for enhanced semantic analysis and NLP-driven foresight modeling for strategic technology planning. But there are some limitations too. This study may not fully capture the entire innovation environment by relying on patent data. Future research will be able to overcome these limitations by integrating other data sources, such as uh, academic publications or industry reports and so on. And this study relies on one model for each analysis. Future work will allow this study to derive the best fit models by comparing consistency scores of different topic modeling techniques, such as LDA and BOT, or different embedding models. Thank you for listening.